We are going to talk about DevOps. This is a DevOps track, I guess. How are you guys doing? Yeah. So the idea of this session is just to introduce what's the latest in cloud native space for DevOps. Probably most of it is a recap for you guys if you're already on cloud native space. The idea is not to go too deep, but just to introduce what's happening and some of the challenges related to data agility, and then probably take some questions, right? With that, let's just talk a little bit about our company, who we are, right? We're a company called MayaData. One of the co-founders, manage operations. Unfortunately, the resolution is not that great, but I'll just try to speak through it, right? So MayaData, as the name says, it's the data and the magic, right? So Maya is the magic. It's all about the data being agile, right? What does it mean is what we're going to talk about. We have taken the path of completely being in open source. We develop technologies in open source, and we groom them, grow them, harden them through open source, and then as the adoption grows, we try to support. That's our model. We also have another project called Litmus, and there's a new emerging project called Node Disk Manager. That's the open source project that's probably is going to go into upstream Kubernetes itself. So these are the three projects that we actively maintain, and the community is growing pretty well and pretty fast too. And we also have another SaaS portal called Maya Online. This is the free SaaS portal for all DevOps engineers who is using Kubernetes. So feel free to take a look at it. So just a bit of introduction about OpenEBS. It's one of the fastest growing communities in open source space. We got about 250 contributors, a lot of GitHub likes, and the Docker pulse is also quite impressive, right? With that introduction, let me just get to the crux of it, right? Just visualize this and see what's the relationship between DevOps and microservices and agility. DevOps is not new, right? I mean, it's been there for some time, but there's a big shift that's happened because of the way DevOps is taking the new path to become more agile, right? So the entire DevOps is being converted into making them microservices based, right? The applications are being converted into microservices. So you develop and then you operate. The DevOps also has to follow, at least rewrite the entire DevOps to move them to container-based microservices. So then what's the relationship, right? So DevOps are adapting microservices, right? Why? Because microservices are enabling agility. DevOps are already good, but you want to be more agile. Probably when you're more agile, your ROI is very good. Probably you will do it in off the time or much less than that with off the cost. That's probably what is driving the need for going towards microservices. So why DevOps are really getting agility, and that's why they're going to microservices, right? So that's the a very quick way of telling what's happening right now, right, at a very highest level, right? Now let's go a little bit into technical. We talked about why DevOps is doing certain things, right? So let's talk about how are they going to microservices, right? Simple. I mean, we all went through this revolution of cloud, but now we are going through another revolution, right, which is nothing but cloud native space, right? You must have seen at the entrance there's a big booth, Cloud Native Computing Foundation, CNCF. That's a foundation which is part of the Linux Foundation, which is driving the whole innovation in this space, right? And most of the technologies that are innovating in this area towards this goal are actually trying to move towards a common goal through this foundation, and then they're collaborating, and then there's a big wave of developers trying to be associated with it, and then try to achieve this goal of being more agile, right? Let's talk about some of the technologies. I just want you guys to say, lift your hands whenever you are familiar with the technology, right? Docker, Kubernetes, Helm, Istio, right? So these are the technology. Now you get an idea, right? So these are a group of technologies that are evolving, getting innovated to achieve this development. OpenEBS is one of such technologies. We are part of Cloud Native Foundation, this group, and then there's another popular project called Prometheus, which is to do the metrics observation collection and do something about how to monitor your Kubernetes clusters. So this is the space which is really helping the entire DevOps to move to microservices. These are the technologies, right? So if you say that cloud native technologies are helping enable the agility in DevOps, right? Then what's agility? Let's talk about it, right? We generally talked about the top level, but agility means different things to different people. And there is an application agility. Let's say that you have web server, which is usually called as also as a stateless application, right? There's no data associated with it, right? You actually write a Helm chart and then it just gets deployed anywhere, right? The image is there somewhere in a container repository like Docker Hub or gcr.io, and then you can move this web application anywhere on a Kubernetes server. It's very easy because there is no data associated with it. It's very agile, right? You can just stop this and then start it anywhere, not just within a cluster, but across the clusters, across the clouds, anywhere. That's the kind of agility we have achieved in the last few years by adopting these container technologies, right? And that's we can also call it as stateless application agility. Let's talk about data agility, right? What about databases, right? Can I take a database and then move it from one cloud to another cloud, one cluster to another cluster, one node to another node? Probably not. That's because there is a data and which still is going to get returned onto the disk, right? Onto the cloud provider system, right? Or onto a local hard disk. So data agility is a much bigger challenge, and that's also going through a big innovation cycle right now. It's called persistent storage or cloud native storage. So these are some of the bigger challenges once the first wave of adoption is completed. So Kubernetes and other things are getting, we are looking into the data agility challenges, and OpenEBS is one of them, right? So if you have to have this data associated and keep the agility still good, you need to have storage, right? That's attached to the container itself, right? That's when you get your container gets mobility, right? So now we are looking at, earlier we talked about, earlier in the sense in the last decade or so, we talked about DAS, NAS, distributed systems. Now there's a new storage that's evolving in open source called container attached storage, right? It exposes all the standard protocols. As a storage engineer, you don't need to change anything, but the way it's architected, the way this entire system is architected is in line with what is the expected behavior with respect to how you control the execution of these containers, right? So that's called container attached storage. We'll talk a little bit more about that. But I just wanted to give an overview of what's the agility challenge that we have. And this next 10-15 minutes, we're going to talk a little bit more about data agility, right? So before we go, I just want to know, make sure that I'm not telling anything new, right? It's in accordance with Cloud Native Computing Foundation. So what's cloud native, right? According to their definition, it's technology that empowers organizations, in order to run these applications in a modern way on public, private, hybrid clouds, right? So at the end of it, what you really get is this laser pointer probably does not work. It's really the high impact changes that you do to your application are really delivered very fast at very less cost, right? That's really what matters. If you're running a DevOps organization or you are a DevOps engineer yourself, what do you measure as a key criteria that you're doing good or extremely good? Is I have a big change that my developers got in, and that's the previous talk about. He demonstrated, he made some change, it went live all the way, right, immediately. But of course, that's a small change. What if you have a very big e-commerce database where there are thousands or millions of users like Flipkart, right? You're doing all sales are going on and you want to actually make a change, a database upgrade or a ERP table change, then what happens? How do you do that, right? And you want to actually move that DevOps into Kubernetes based DevOps, what are the real challenges, right? So it all comes down to whether you're able to do it very quickly or not. That's the key criteria to measure whether DevOps is really working well or not. So one of the famous examples is GitHub itself, right? GitHub is a SaaS platform and there are a lot of databases underneath. So the GitHub developers, they say that, we do the check-in into the GitHub code, the backend code, and it goes live almost immediately because we got a system of checkings and testing and verification that things are going to go okay. If they don't go okay, they roll back, all that stuff. So that's an example of very agile DevOps, right? So that's really the key to being agile, right? So just let's recap what are those real challenges and what are the solutions for being data agile, right? So high availability, as we just discussed, is a key challenge, right? You take a stateless application, move from one node to another node. You don't move, Kubernetes just reschedules it. And then what happens to the stateless application, right? So when you move to microservices architecture, your legacy application is broken into multiple containers. It's not just one application anymore. You got stateless applications, and then you got stateful applications like database. Database runs really in a separate container. Data is stored elsewhere, and then your web services runs in separate container, right? So when this high availability really needs the data to be available wherever the pod gets moved by the orchestration framework, right? So what is the challenge is, the challenge is to have synchronous replication of your cloud native data, right? So your data has to be available wherever your pod moves, wherever your database pod moves, right? So, and also the same challenge is there across the clouds as well, right? We keep talking about multi-cloud. Multi-cloud, what's an example of a multi-cloud, right? So for example, your GitHub, your code is in a cloud, which is GitHub, and your developers are using Kubernetes on-prem, right? And your CI/CD is running on Google Cloud, right? And then your pre-prod actually deployment is happening on another cloud because there are various reasons why we do that. And then your production of your hosted solution is happening on AWS. It's all one application, but you're using multiple cloud architectures and to your advantage, right? And this is being powered by the availability of Kubernetes, right? So what happens to the data, right? So that's the big challenge, right? So it's not just the stateless application you want to be able to move, your databases also need to be able to move across all these clouds. So one of the challenges move the data across the clouds, right? And then you develop, and then you have to move it into the CI/CD pipelines. Earlier CI/CD is all monolithic, but now you want to reconstruct your CI/CD pipelines in order to move them to cloud native space, right? So there are some data related challenges in your CI pipelines, and primarily the developer wants to be really agile. That really means he checks in the code, and then within next 5-10 minutes you get a mail that there's a problem with your check-in, something broke in your CI pipelines. Okay, what broke? I want to be able to look at as a developer, right? And it's related to the data that's stored at that point of time when the failure that happened, right? So you want to be able to provide the developer with a snapshot and a clone of that particular database at the point of time of failure, so that he or she can debug and then move across, right? So the main challenge here is your pipeline that you are building as part of your DevOps microservices, are you able to take the data snapshots in pipelines, right? That's another challenge, right? Okay, your development is done. What next? You need to really put it into production, right? And this is the crux of the any organization for whatever the product that they're building. The testing is the key part of it, where that's the last gate before your users are taking advantage of the technology that you developed or the code that you fixed, right? So however good your technology is, you need to make sure that the testing gets done properly. And then as you break your monolithic into multiple containers, people are pushing out the changes very often. For example, MySQL maybe making a release 8.0 to 7.0 to 8.0 in 1 year time frame earlier, but now as they also adopt the agile technologies like DevOps and microservices, the releases are like they're getting faster and faster. For example, you might get a standard MySQL image now, and next week there's one more image available, right? Like that, there are about 10 technologies that are there in your pipeline. How do you actually test all those things for a small change that you made, right? And you want to get the latest technology, and then how do you see whether the new functionality introduced in MySQL is not affecting my present scenario, which I don't even know whether it affects or not. So idea is to have a matrix of end-to-end tests that covers all these scenarios, right? You are already having a challenge of how to move to Kubernetes and how to actually make my application into microservices architecture. Now you are bringing me the other challenges of now I have to rewrite my entire E2E, right? Entire CI pipelines, all those things, right? So app-specific data resiliency and availability will become a challenge if you don't have a good E2E platform, right? That really means that you don't have enough test cases or test scenarios in your pipeline, and there's no way whether your data will continue to be available just because you made an update. An update could not be related to you, it's done by someone else because you are following the container technologies, right? So finally, let's say that you move into production as well, and then most common thing is to have data means you have to do backup, restore, DR, all that stuff, right? So there are some challenges in that area as well, right? So traditional backup systems, whatever your DevOps is using for years, now will not work because you moved on to Kubernetes. I mean, you're getting a lot of advantages, so this is another area which you need to rework on, right? So you need to have a strategy around how to back up your data and then recover it whenever you want, right? So backup and DR for cloud native data is totally different. You need to have a strategy, right? So just to summarize, right? So what are the challenges and what are the technologies that you may be wanting to use in general in open source, right? So the challenges are, we just discussed, right? The technology has to have synchronous replication of cloud native data, and then ability to move the data across the clusters, ability to have data snapshots in pipeline, being able to build E2E pipelines very, very quickly, and then also to have a backup strategy, right? So these are some of the open source technologies that can solve this data agility problem. As we discussed, OpenEBS is one of such architectures. There are a couple of others, right? And CAS is container attached storage. And we also have this Litmus project where you have a lot of test suites that are custom made to run on Kubernetes for various applications, which you can just use and use them right away, right? You can construct a CI/CD pipeline within hours, right? For whatever the database application that it could be, right? So similarly for data backup and restore, there's a famous project called Heptio.org, and it provides plugins for various other cloud native storages. For example, with OpenEBS plugin, you can use Heptio.org to get the right backup strategy, right? So that's kind of a summary of it. Maybe I can take one question before I go deep into it. I mean, is this helpful? Any questions in the middle? MayaData is a company which is sponsoring this open source projects. Yes, we are investing into the development and promotion of these open source technologies. Right. It's all the projects are available under Apache 2, which really means that we cannot show any ownership. It's just that the governance is being done by a particular company. All right, let's take a look at this open source technologies, OpenEBS, Litmus, maybe Heptio.org, a little bit more on how these are architected maybe, or what they are. Sorry about the resolution, probably it should have been a little bit bigger. So the whole idea is in the container attached storage, your storage software is also a microservice, right? It runs completely in user space. This is the first time you may be hearing, where traditionally storage controller means it's in a box, it's in a kernel, all that stuff, but this is a new age storage architecture where the storage software runs on the user space, so that it can become a complete microservice. So the advantage of this is, whenever you want volume, some data volume, right? You don't need to do anything. You ask the OpenEBS provisioner, it just goes and carves out certain disk space somewhere and puts links that to a storage controller which is in a user space, right? That really means that you have MySQL database running in a container. You ask for storage volume to store the data. You will get a storage pod which is dedicated for that volume. You can customize that pod for various storage policies for this application, and then it gets automatically written into the data, and then all the load balancing, high availability, fault tolerance. It's like an enterprise grade storage, right? So you get a containerized storage controller per application, right? So the next thing is Litmus, right? Chaos engineering is one of the most common new age practices that the modern day companies and DevOps are practicing nowadays, right? So the chaos engineering is really nothing but you don't wait for fault to happen. You actually introduce the fault not just in your pipelines but also in production, right? And then what happens when you introduce such a practice, right? So Litmus is really geared to provide some infrastructure and tools to achieve that practice in your day-to-day DevOps life, right? So it really provides certain tools to deploy KITS here and there, and then it really provides various books. We call them as Litmus books, named after Ansible playbooks, right? These could be like underneath an Ansible playbook, but it could be some other technology. But we provide a package. Litmus provides a package to provide the ability to run a particular task as a KITS job, right? And that's the crux of it. Right now, you want MySQL. There are like tens of MySQL test cases that are already there that are written specifically to be to be run on KITS. And because it's open source, now MySQL developers can go and add more. They don't need to manage a separate set of test cases. They can add it to here. So as it grows, you have a huge suite of various tests that are available in open source to be run on Kubernetes, right? And how Litmus is used is, it's in the middle of a pipeline. You basically set up a pipeline using GitLab or Jenkins, something like that, and then you almost have readily runnable Litmus jobs that you can just insert as a stage, and then all your pipeline gets completed, most of it rather, right? And we talked about Heptypo.org, right? So Heptypo.org is also a well-known technology. Along with the OpenEBS plugin, you get the ability to take your incremental cloud data backup onto an S3 or some other target, right? So how it works, sorry about the resolution again, it's quite straightforward. There's an Arc controller and an Arc agent. It just sends out a message saying that now is the time to take a backup. The storage takes a snapshot and then moves it to a different target. So these are pretty well known in our regular storage. If you're a storage administrator or you used storage in an enterprise world, you all know this, but these are the new ways of doing the same thing in cloud native space, right? So let's summarize. I know it's lunchtime. Just to summarize, DevOps requires data agility. For that, you need to choose the right storage to provision and build the snapshot aware pipelines, and then make sure that you build the E2E tests that are more generic rather than you writing yourself using Litmus or something like that, and then choose the right backup story or restore technology. So if you follow these best practices, you are bound to get data agility, right? This is like very top level introduction. This, OpenEBS is a very well-known project for its ease of use and simplicity. So hopefully it's easier to get started. If not, we're all on Slack channel called OpenEBS. You go to slack.openebs.io. We should be able to you should be able to get in touch with us, right? So let's just give an example before we take more questions or end the session, right? So this is how your system looks like, right? You have developers in your organization and you have some architects, right? And typically the clusters are of many types, right? You have a developer Kubernetes cluster, and then there is a production cluster, there is a CI/CD or pre-prod clusters, right? If this is the case, right, so usually what happens is people, developers want to develop the code, and for that they need some persistent storage during development, right? Persistent storage required for a developer can be done in a fraction of a second with OpenEBS, for example. You just need to tell what's the size of the persistent storage you need, and OpenEBS provisioner can actually carve out the storage and give it to you, right? So developer, he or she does not need to worry too much about how do I get persistent storage, right? So that's one way, right, if you use CAS architecture, right? So, and then it's all done, the code is merged, right? If the code is merged, the pipeline starts automatically, right? So pipeline started and the build stage is done, and all your Kubernetes, new Kubernetes cluster or new infrastructure gets spawned on the fly, and then you actually get start with litmus tests, right? You pick and choose whatever the litmus test you want for running your particular test, and then once all the tests are done, you are basically going into the continuous deployment stage, right? So it gets deployed into the production. So let's just say that this is not as smooth as this, and then one of the litmus test fails, right? So then what happens? Ideally, what should happen is the developer should get access to what was the state of the database at which time it failed, right? So automatically you should be able to take a snapshot of that stage that failed, and then clone that data into another volume, and then a developer should get access to that data, right? This is all happening in like few minutes. Just imagine you check in the code, I get a Slack message or I get an email, hey Mr. Raghav, sorry, there is a problem, it failed, your code really did not pass all the tests, and here is the database snapshot, access to a snapshot, go and debug. Just imagine how much time you saved, probably days, right? You don't need to have a super big DevOps team, right? Just one guy just to make sure that it runs. Not really like you have 500 developers, 5 code check-ins are happening every like a day or hour, and then how many DevOps engineers you need to have in order to support this kind of a development. So that's, if you have this, the data agility comes very fast, right? So you can be rest assured that things will go smooth, right? So that's an example of the pipeline thing, right? So now let's say that after all that the deployment is done, and then comes the chaos engineering. Chaos engineering is even after it goes into the production environment is always different than your staging, however close you bring it, right? So you still need to introduce chaos engineering tests into the production if you are really following this the latest cloud native principles, right? So that's where the litmus can help, and you can integrate that into your DevOps pipelines as well, right? So the last stage is backup, right? So use OpenEBS and Heptio Arc together to put your backup onto object storage like S3 or MinIO, or there are other choices. For example, Maya Online also provides a backup target, right? So that's the kind of a summary, right? How you achieve data agility if you follow the the latest DevOps principles, right? And the end result is you should be able to get the data agility delivered, and you are a high performing DevOps team already, right? So I can take some questions. Obviously this talk is about DevOps, and we need DevOps engineers.
Sorry, Kubernetes is implemented by a lot of the major players, Azure and
yes.
Google Cloud. So OpenEBS, is that also implemented?
That works seamlessly with Kubernetes is the cloud storage, not the local disk. So you are not able to use the local disk for your need, even though they are available. With OpenEBS, that problem gets resolved. So you can actually use the local disk and then have a yes on all, we have users on all clouds.